In this video, we will be treating electricity and chemistry, popularly known as electrochemistry or electrolysis. Here, there are some basic concepts like the word electrolyte, electrolysis, cathode, anode that you will come across. But in the first case, what is electrochemistry or what is electrolysis? Electrolysis is the passage of an electric current through an electrolyte, be it in a molten state or in an aqueous solution, causing it to decompose into the different ions. You pass an electric current in an electrolyte through an electrolyte, which could be in a molten state or in aqueous solution, and the solution will not decompose into the various ions in it. Then, what is an electrolyte? An electrolyte is a liquid that has been chemically changed by an electric current, making it to conduct electricity. This liquid that has been chemically changed by an electric current, causing it to conduct electricity. So all electrolytes are good conductor of electricity. They are good conductor of electricity. But what happens? What happens during electrolysis? That is the most important thing. What happens during electrolysis? Take for instance, this is an electrolytic cell. This is a cell. In this cell, we have the electrodes. These are the electrodes. We have the cathode. We have the cathode. What is the cathode? The cathode is the negatively charged electrode. This is the negatively charged electrode. This is the anode. This is the positively charged electrode. And this is the power source. Electrons will flow and enter the electrodes, enter into the solution or into the electrolyte, flow through the electrolyte and back into the electrode and continue circulating like that. That is how the current flows. In that case, when current passes into the electrolyte here, it causes the electrolyte here to do what? To decompose into the different ions. The cations will go, the anions will go. This is the substance. This is a compound. An ionic compound. This is an ionic compound in this situation here. So when an electric current is passed through this ionic compound in an aqueous solution, what happens? This ionic compound is decomposed into the cations and into the anions. And all these, the cations will now go to the negatively charged electrode, which is the cathode. And the anions will now go to the positively charged electrode, which is the anode. So in all, we can summarize that during electrolysis, During electrolysis, we can say 1 at the cathode. During electrolysis at the cathode, what happens? After the metals will break away from the anode. At the cathode, what happens? Metals are deposited at the cathode. Metals are deposited. Metals deposited. Metals are deposited at the cathode. At the anode, what happens? At the anode here, what happens is that the metals will break away from the anode. Metal breaks away from the anode. The metals will break away from the anode. That is what happens. Then again, at the cathode, what happens at the cathode? At the cathode, you will see that hydrogen is evolved at the cathode. Hydrogen will be deposited at the cathode or be released as a gas at the cathode. Hydrogen is evolved. Hydrogen is evolved at the cathode. That is what happens. Then at the anode, you will see that at the anode, you will also see that non-metals are discharged at the anode. The non-metals are discharged at the anode. The non-metals are discharged. If you look at it critically, non-metals are discharged here. Here, so at the cathode, we say the metals are deposited. 1, metals are deposited. 2, hydrogen is released. At the anode, we will now say metals break away from the anode. Metals here, the metals will break away. Metals are breaking away from the anode. And the non-metals are doing what? Non-metals are being discharged. Non-metals are being discharged. So in that case, that is what is happening at the anode. I mean, that is what is happening during the process of electricity. Once more, an electric current is passed through the electrolyte, which is in solution, and it causes this electrolyte to decompose, to break down, or to split into the different ions, whereby the cations will go to the negatively charged electrode, which is the cathode, and the anions will go to the positively charged electrode, which is the anode. That is simply what is going there. While at the cathode, the metals are deposited, hydrogen is also evolved, and the anode, only non-metals are discharged. Now, it drives us to, this now drives us to the second section. How do we know which ion is discharged at the cathode or at the anode? Which ion is discharged at the cathode or at the anode? The ions that are discharged on the cathode or at the anode will depend on their position at the electrochemical series. This is a chart of the electrochemical series. The cations are arranged and the anions are arranged. The cations beginning from potassium right down to silver. This is the ease at which they give electrons. As you go down this column here, the ability to give electrons decreases, with potassium having the highest tendency to lose electron. The same thing with the anions. The anions here, as you go down, fluorine is the most electronegative. having a high affinity for electrons. As you go down, the ability to accept electron decreases, with fluorine having the highest ability to accept electron. So this chart simply gives a simple explanation on how you can easily decide, you can easily choose which of the ions is easily discharged. In case of the cations, if you have 2 or 3 cations in this situation, the cation below the cation below the other one has a higher tendency to be discharged. For instance, if I have hydrogen ion and a copper ion discharged at the cathode, the one likely to be discharged first is copper. The one below in the electrochemical series takes the priority. The same thing if I have 2 anions. Let me say I have chlorine and I have OH, the chloride and the hydroxide ion. If I have these 2, the one of a higher priority will be what? It will be the hydroxide ion, the one below in the electrochemical series. Hydroxide ion will take priority over this one, chloride ion. It will be the one to be discharged. Just as I said, if I have hydrogen ion and a copper ion, copper will now have the priority to be discharged over hydrogen ion. So their position in the electrochemical series determine which of the ion is discharged and is discharged at the electrode. Then another factor that will also determine which of the ion is discharged is the concentration of the ion. The concentration. The higher the concentration, the higher the concentration, the higher the position, the higher the possibility of it to be discharged. The higher the concentration, the higher the possibility of it to be discharged. Remember, the cations will move to the cathode and the anions will move to the anode. At the cathode, there is a reduction that is occurring there. At the cathode, there is a reduction that is occurring there. At the cathode, there is reduction that is occurring there. The positively charged ion will not give what? Will not give back the electron. They will the positively charged electron or positively charged ions, the cations. Sorry, please. The cations will gain the electrons. They will gain electrons, thereby doing what? Are being reduced. So at the cathode, there's a reduction that is occurring there. At the cathode, there is reduction occurring there. At the anode, know that the anions go to the anode. The anions at the anode will do what? They will undergo oxidation. They will undergo oxidation. They will lose electron. They will lose electron. They will lose electron, thereby undergoing oxidation. Meanwhile, the cations will gain electron, thereby undergoing what? Reduction. So it's a redox process that is occurring in this cell. The cations will gain electron and undergo reduction. Meanwhile, the anions will lose electron and undergo oxidation. So now it drives us to our first example, which will be electrolysis of molten. Our first example will be electrolysis of molten magnesium chloride. electrolysis of molten magnesium chloride. Remember, in a solution, in a situation like this one, remember in a situation like this one, molten magnesium chloride, what happens? If it is molten, there is no water involved. If it is molten, no water is involved. But if it is aqueous, if it is dilute, water is involved. Water is involved. So in this situation, no water is involved. In this situation, no water is involved. Therefore, if no water is involved, what happens? There are two ions that are there. The two ions are, we have the magnesium ion, the magnesium ion, which are the cations, and the chloride ion, which are the anions. As we said, the cations will go to the negatively charged electrode, which is the cathode. So magnesium ion will now move to what? Will attracted to the cathode. Meanwhile, the chloride ion are attracted to what? To the anode. So let's write our half equations. Let's write our half equation, equation of what is occurring at the cathode and what is also occurring at the anode. Okay, as I told you, at the cathode there is reduction that is occurring there. Reduction process is occurring here. Reduction. Remember, oil rig. Oxidation is loss of electron. Meanwhile, reduction is gain of electron. So now at the cathode, what is happening at the cathode? At the cathode, magnesium will gain electron. Magnesium will gain electron. This is what is happening. Excuse me, please. Again, then at the anode, what is happening at the anode? At the anode, what is happening at the no, at the anode? At the anode, the chloride ion will do what? The chloride ion will lose electron. So what is happening here? What is happening at the anode is oxidation. Oxidation process is taking place at the anode. The chloride ion will do what? They will lose electron. The chloride ion will lose electron to form the chloride to release the chlorine gas. To release the chlorine gas. Meanwhile, at the cathode, magnesium will do what? Meanwhile, at the cathode, the magnesium ion will gain electron to be deposited as magnesium solid. Okay, let's go to electrolysis of molten sodium chloride. For molten sodium chloride, we said that at the anode there is oxidation. At the anode, oxidation is taking place. Then at the cathode, what is happening at the cathode? At the cathode, there is reduction. Now, we have molten sodium chloride. Again, there's no water involved. So the only two ions there are the sodium ion and the chloride ion. The same thing that happened up with molten magnesium chloride is going to happen here. So here at the cathode, as we said, the cations will move. The cations will move to the negatively charged electrode. The cation will move to the negatively charged electrode, which is the cathode, and the anions will move to the positively charged electrode, which is the anode. So at the cathode, what happens? At the cathode, there is a sodium ion that is deposited there, and at the anode, there is the chloride ion. So at the anode, what happens at the anode? The chloride ion will undergo oxidation, loss of electron. So the chloride ion will lose electron. To balance the chloride with the chlorine. So chlorine gas is released at the anode. Chlorine gas is released at the anode. Meanwhile, at the cathode, what is happening at the cathode? There is sodium that is deposited there. So what happens? The sodium ion is positively charged, so it must do what? Sodium must gain back the electrons. Sodium the sodium ion must get back that electron to be deposited as a metal at the cathode. So the sodium will gain electron. Sodium will gain electron to be deposited as the sodium solid at the cathode. In that case, sodium is reduced from +1 to the solid metal. Now here, chloride ion lost the electron to be released as the chlorine gas. From here, it is oxidized from the chloride ion to what? To the chlorine gas. That is from -1 to 0. in terms of oxidation number. Then this one is reduced from +1 to 0. Reduction, oxidation taking place simultaneously. It drives us to another example, which is electrolysis of dilute sulfuric acid. Electrolysis of dilute sulfuric acid. What is happening in the cell? As we said, dilute, when it has to do with dilute or aqueous, it means water is involved. So water is going to release two ions, the hydroxide ion and what? And the hydrogen ion. So the hydroxide ion, when it comes to water, the hydroxide ion, when it comes to water, will go, the hydrogen ion, will go to the cathode. Water will produce plus, and it will also, which will come to the cathode, which is negatively charged, and OH, that will come to the anode, which is positively charged. Now again, sulfuric acid will produce two ions, the hydrogen ion and the sulfate ion. The hydrogen ion again will come here. The hydrogen ion will come here again from sulfuric acid, and the sulfate ion will come here. The sulfate ion will come there. What is happening? The two ions, as I said, water will release this and this. Acid will release this and this. So the two will go to the cathode and the anions will go to the anode. Now, what is happening now? Between this, hydrogen ion will take the priority. Here, which one will take the priority? It now takes us to what? It now takes us to our electrochemical series. Let me take you back to the electrochemical series, the OH ion and the SO4 2 ion. Now, we are here again. We have this ion and we have this ion. Which one will be discharged? The OH ion, because it is lower at the electrochemical series. So it takes the priority. So OH will be taken. Okay. The OH ion now is taken. OH ion now is the one to be taken. That's it. Let's write our equations. Our half equation. Under cathode will undergo reduction. Cathode will undergo reduction. And the anode will undergo what? Anode will undergo oxidation. Under reduction, what happens? Under reduction, oxidation is loss of electron and reduction is gain of electron. So what is happening? Hydrogen needs to gain the electron back. So we have hydrogen, the hydrogen ion, plus electron, to give what? Plus electron to give what? To give the hydrogen gas. We need to balance we need to balance our electrons and our hydrogen. So we put a 2 here. We will need 2 electrons to neutralize it. We'll have 2 electrons. We'll have 2 electrons. So now we have this as we have 2 hydrogen ion and 2 electrons to give us a hydrogen gas. That is the reduction process, half equation. Now, on our oxidation half equation, what is happening? Since we took OH, what is OH going to do now? OH is going to undergo oxidation. Oxidation means what? Loss of electron. So what do we do? The equation is like this. We lost electron to form water. To form water, oxygen is released. Oxygen is released plus electrons. We don't know the number of electrons. Let's see how we can balance it. Here we have oxygen here. We have 2 here. We put a 2 here to balance the hydrogen. If we put a 2 here to balance the hydrogen, it will not balance the, so we put a 4 here. If we put a 4 there, it will balance the OH. Then, if we put a 2 here, it will balance the hydrogen. If we put a 2 here, it will balance the hydrogen. It will be 4 hydrogen, 4 hydrogen. 2 oxygen on this side and 2 oxygen on this side. With 4 oxygen here, it balances everything. Then, electrons are still there. There are 4 here. 4 times the negative charge here. There are 4 negative charges here. So to balance with electron, what do? We put a 4 here. So we have 4 electrons. We now have 4 electrons there. So that is how it is. 4 electrons. Okay. Let's move forward. Okay. It takes us to electrolysis of dilute sodium hydroxide. Electrolysis of dilute sodium hydroxide. What happens with electrolysis of dilute sodium hydroxide? Or they can say electrolysis of aqueous sodium hydroxide. So what happens? Here we have sodium hydroxide here. It is dilute. Water is involved. So water here will produce hydrogen ion and OH ion. Water will give rise to what? Will give rise to hydrogen ion and OH. And sodium hydroxide will give rise to, since dilute, sodium hydroxide will give rise to what? Will give rise to sodium ion and the OH. And the OH. Now, which of them will go to the cathode? Which of them will go to the cathode? At the cathode is, we said it is negatively charged. And the cathode is negatively charged, is going to host the cations. So water, it is here that comes, this one comes here. This one comes here. And from here, the other one also comes here. Now, at the anode, the anions will go there. So here, OH comes here. The OH will go there, and from here it's still the same OH that will be there. So that is what is happening there. So it's the same OH everywhere. So the equation now is, what is happening at the cathode? As we said, reduction is taking place. Reduction is taking place at the cathode. The cathode reduction is taking place. Meanwhile, at the anode, oxidation. Now, sodium ion and hydrogen ion, which one should be taken? You know it, as I told you. As I told you, fellow learners, make sure you know the electrochemical series very well. The electrochemical series will guide you to know which of the ion is easily discharged. Between sodium and sodium ion and the hydrogen ion, which one it will be taken? The one of priority is hydrogen ion. So learners, remember this during your exams. Okay, now here we are going to take hydrogen. In taking hydrogen, what do? Hydrogen is going to undergo what? Hydrogen is going to undergo reduction. That is gain of electron. Hydrogen will undergo reduction, will gain electron. To form what? To form the hydrogen gas. To form the hydrogen gas. And we need to balance the electron. How do we balance the electron? Balance the hydrogen by putting a 2 here. And we have a 2 here. There are 2 positive charges here. 2 times positive is 2 plus. Then in order to balance the electron, what do we do to neutralize this one? We need to put another 2 here. So now, the same thing goes to at the anode. What happens at the anode? What happens at the anode? At the anode, is OH. At the anode, it is OH that is there. So OH at the anode will do what? Is going to do what? Is going to undergo loss of electron. So this is what happens. The OH loss an electron to get molecule of water. Oxygen is being released. Lost electron. We need to balance the electrons. What do we do? In order to balance the electron, what do we do? To balance the electron, we need to balance it with a 2. We put a 2 here, the same thing will happen. We put a 2 here, it will not go. If we put a 4 here, it will go. There's 4 hydrogen here, so we put a 2 here. We put a 2 here. 2 hydrogen, 2 times 2 is 4. 4 hydrogen. Okay, oxygen 4. 2 hydrogen, 2 oxygen, and the 2 oxygen. It balances the situation. But there are 4 ions on this other side. What must we do to do this? We must balance them by putting a 4 here. We must balance it by putting a 4 there. So that balances the whole thing. A gas, this liquid, and this is what? And this is gas. So in this situation, we have taken, in this equation here, hydrogen has been taken and the OH has been taken. Hydrogen has been taken and OH has been taken. So what is left in this in solution? What is now left in solution is what? Is sodium hydroxide. When hydrogen is released at the cathode and the oxygen at the anode, the solution remains as sodium hydroxide. Okay, that is how you can write your equation for this. Electrolysis of dilute sodium hydroxide. It takes us to the next step, which is electrolysis of copper sulfate using active copper electrode. Electrolysis of copper sulfate using active copper electrodes. Remember that, you should remember that here, all what we have been using right from on the onset they are inert electrodes. The cathode and the anodes are inert. They don't react. So now we are going to deal with electrodes that are active. Electrolysis of copper sulfate using active copper electrodes. Now the two electrodes, the cathode and the anode are all made of copper. They are made of copper. All the two electrodes here, this is made of copper. This is copper. This is copper. All of them are copper. The electrodes are copper. But what is going to happen here? There is copper sulfate in this solution here. Of course, it's going to go the same way. It is going to go the same way. Now, water is going to give what? As I said, water will give rise to the hydrogen ion and the OH ion. And the copper sulfate will give rise to the copper ion and the sulfate ion. That is what is happening there. But remember, there is something at the cathode. What is going to happen? The reaction this time around is going to change because all the electrodes are active electrodes. So what happens here is that at the excuse me, at the cathode, copper 2 is deposited. There's copper 2 at the cathode. From here, copper 2 goes here. From this solution here, there's copper 2 here in the solution here. So the copper 2 will go to what? Will go to the cathode. There's copper 2 here, come here. The copper 2 will go there. The copper 2 will go here, and the sulfate will also go here. The copper 2 will go and the sulfate will go here. But what is really going to take place entirely? The sulfate has nothing to do here. The sulfate will have nothing to do here. So the reaction at the cathode, will be this one. The reaction at the cathode will be, as I said, at the cathode, there is reduction that is taking place there. Copper aqueous plus 2 electrons to give copper solid. This is what is happening at the cathode. There's reduction occurring there. The copper ion will get electron. The copper ion will gain electron to be deposited as the copper ion will gain electrons to be deposited as the copper metal at the cathode. On the other hand, at the anode, we know at the anode, the sulfate has gone to the anode. But remember, they are active copper electrode. This electrode is copper, is made of copper. This other electrode is made of copper. The anode is made of copper. So for that reason, the copper will break down to what? The copper will break down to what? It will break down to the copper ion. In that case, this copper is going to release it breaks to what? It breaks to a copper ion and enters into the solution. This copper ion now comes into the solution again. The copper will breaks to copper ion. The copper ion now enters into the solution. And in the solution, what happens? The copper ion will now leave what? In solution, they will now move to what? Will now move again to the cathode. Will now leave here and move to the cathode. And when they get to the cathode, what happens? At the cathode, they leave the solution and then move to the cathode. And at the cathode, they will do what? They will get electron again, this time around. So when they move, once more, the sulfate released in solution is not going to do anything because the electrode is active. Because the copper electrode is active, it will break. The copper will break and get into solution as copper ion. And when it gets into solution as copper ion, it does what? It now moves towards the cathode. And at the cathode, it will do what? It will now gain electron. It will now gain electron and be deposited as copper solid. It gains electron and be reduced and deposited as what? As copper solid at the cathode. That is what happens. That is what happens. Learners, be reminded that this process is usually used in electroplating. This process is usually used in electroplating and in copper refining. A recap. During electrolysis, I said during electrolysis, there is an electric current that passes through the electrolyte to break down the substance into the different ions. and the cations will move to the cathode, and the anions will move to the anode. And they are discharged at the cathode, at the different electrodes. The thing when it moves us to the level, to another level. How do we know which of the ions are discharged, either at the cathode or at the anode? It drives us to knowing well or remembering our electrochemical series, the ease of discharge of the different ions at the cathode and at the anode. Learners, do put this in your memory very well. You from here, the anions below in this series are given priority, and the anions below here are also given priority. Then we went further for molten magnesium chloride electrolysis. Remember, with molten, when it is in a molten state, water is not involved. So in that case, there are only two ions that are involved: magnesium ion and the chloride ion. And we said at the cathode there is reduction, and at the anode there is oxidation. Then we can write our half equation. At the cathode, the cations will get electrons to be deposited as a solid. They will get electrons and are reduced to the solid and are deposited at the cathode. Meanwhile, at the anode, the anions will lose the electrons. They will lose electrons and are released as gas. For example, in the case of the chloride ion, chloride is released as the chlorine gas. It went further for the electrolysis of molten sodium chloride, which is the same procedure for magnesium chloride. Then we went further for electrolysis of dilute sulfuric acid, and I said when it is dilute or when it is aqueous, water has two ions, the hydrogen ion and the OH ion to release, and the sulfuric acid itself has hydrogen ion and the sulfate. Then now at the anode we have two ions, the hydroxide ion and the sulfate ion. Now which the next thing will be which one is given the priority, the one lower at the electrochemical series, and in that case the OH ion was given the priority, and we can now write our reduction and the oxidation reaction simultaneously. Okay, it also led us to the electrolysis of dilute sodium hydroxide, which is the same thing. We had sodium and hydrogen, but hydrogen was given the priority at the cathode, and we had the OH, the OH, and the OH was the one. Obviously, OH will always release water and the hydrogen gas. Meanwhile, hydrogen is reduced to hydrogen gas, and OH will release water and the oxygen gas. Then it took us to using active electrodes. Now we are using two active the same active electrodes. For example, copper. Electrolysis of copper 2 sulfate using active copper electrodes. As I told you, water will give a hydrogen ion. Water will give hydrogen ion and OH. Copper will give copper ion and sulfate ion. The cations will go to the cathode, and in that case we had copper and hydrogen ion. Copper and hydrogen ion was supposed to be here. Copper and hydrogen ion. Then in this case, at the anode, we will also have the sulfate. But remember that since they are active electrodes, at the cathode, the copper in solution does what? Will get electron and is reduced to copper solid. Okay, at the anode, what happens? The sulfate will not do anything because the electrode is active and the electrode is copper. So this electrode does what? This electrode, which is copper, will do what? Will break. When it breaks, it releases what? Copper ion. It releases copper ion into the solution. The copper ion, while in the solution, will do what? Will be attracted towards the cathode. And when they are attracted towards the cathode, what will be the next thing? The copper ion now will get the same electron and be reduced to copper solid. So sulfate will have no use when we are using copper active electrodes. Thank you, learners. Once more, like, share, and subscribe. Continue watching our videos.